Hello, welcome to this installment of Quadrilaterals. First, we're going to talk about what a quadrilateral is. A quadrilateral is a polygon with four sides. Of course, we know the basics: trapezoids, parallelograms, squares, rectangles, kites, rhombuses, and then you have just your basic quadrilateral. Okay, now we're going to go into more depth. First, we have a trapezoid. Trapezoid is a quadrilateral with at least one set of parallel sides. We denote a parallel side with a triangle on the two sides that are parallel. For trapezoids, you have different kinds. So you have an isosceles, a right, and you denote right triangle, right trapezoids by putting a square in the corner, and then you have a scalene. All trapezoids have the property the consecutive angles between parallel sides are supplementary. So imagine, and I'm going to do this on the scalene, that this side, we know that this side is parallel to this side, so then this is our, I'm trying to draw this on here, is our transversal. So then we know that this angle is 1 and this angle is 2, and those two are alternate interior angles, so we know that 1 is congruent to 2, and if we call this angle 3, we know that 2 and 3 are supplementary. Since 1 and 2 are congruent, we know that 1 and 3 are supplementary. So therefore, all consecutive angles between parallel sides, so 1 and 3, are supplementary in a trapezoid. Next, let's talk about more specifically about isosceles trapezoid. So isosceles trapezoids can be defined as the base angles are congruent, or you could also define them as the sides are congruent, as one set of sides are congruent. We know that with the properties that we have that the consecutive angles between parallel sides are supplementary. Then we have the base angles are congruent by the definition. That tells us that the opposite sides are congruent. The third thing we know is that the diagonals are congruent. And that's powerful. And we're going to use that throughout the rest of this. So that tells us that we have those diagonals congruent, so that kind of pushes everything to be where we want it to be. So next, we're going to talk about parallelogram. Parallelogram is a quadrilateral with both pairs of opposite sides being parallel. This tells us that we have all the properties of a trapezoid. Consecutive angles are supplementary. We know that opposite angles are congruent. With the additional property with parallelograms is that the diagonals bisect each other. So let's talk about this. So we know that this angle is congruent to this angle, and we know that this angle is congruent to this angle. We have that this side is congruent to this side. Wait, I need to put double bars, okay? And we have that this side is congruent to this side. We now know that, I'm going to very carefully draw these in. We now know that this diagonal is bisected, so those two lengths are congruent, and we know that this length is congruent to this length. So those diagonal now lengths are congruent. So now we know that triangle A is congruent to triangle B, and that triangle C is congruent to triangle D. The other thing we know is that if we have the diagonals congruent, if we have that the diagonals are bisected, then we know it's a parallelogram. It goes both ways. If the diagonals are bisected, it's a parallelogram. If it's a parallelogram, the diagonals are bisected. All right, next, let's talk about a rectangle is a quadrilateral with all four angles congruent. It has all the properties of a parallelogram, so that means that it has all the properties of a trapezoid. It has all the properties of a parallelogram, and it has additional properties in that all the angles are right angles because they're all equal. And if I have that all the angles are right angles, then I know it's a rectangle. If it's a rectangle, they're all right angles. And all the diagonals are congruent and bisect each other, then it's a rectangle. If they're congruent and bisect each other, it's a rectangle. If they're congruent and bisect each other, then I know it's a rectangle. It goes both ways. So if I want to show something that's a rectangle, then I can show that the diagonals are congruent and that the diagonals bisect each other if I know nothing about the angles. Because remember that if I want to show something is a rectangle, I either have to prove its definition, or I have to prove the diagonals are congruent and bisect each other. Those are the only two ways to prove something is a rectangle. And you're going to be doing that. You're going to be showing something is a rectangle. Kites. Kites are quadrilaterals with two pair of adjacent sides that are congruent. So you have the convex kite and you have the concave kite, or the Pac-Man kite. So what this means is that this side is congruent to this side, and this side is congruent to this side. Or here we have here and here. And most people forget about the convex kite. Now, properties. The lines containing the diagonals are perpendicular to each other. So if I draw this line and I draw this line, then this angle right here are perpendicular to each other. If I draw this line, hello, that wasn't as smooth. And if I draw this line, then this is perpendicular. Next thing is that the diagonals bisect. So this bisects and this bisects. It doesn't, the long diagonal in the convex kite is not bisected, just the short diagonal. In the concave kite, the diagonal that's outside is bisected, not the one that goes through the inside. Okay, so only one diagonal is bisected, not the other. One diagonal bisects the angles. So here's the other thing. These angles, and it's actually, these angles are bisected, and it's actually all the angles. So even this angle is bisected. So these angles are bisected. Over in the convex, it's only this angle, because this angle is not cut. But what you do find, what is interesting is that this angle and this angle are the same. Next, we're going to talk about rhombus. A rhombus is a quadrilateral where all the sides are congruent. So a rhombus is a baseball diamond. So all these sides are congruent. They're also parallel. So all these sides, or not all of the sides are parallel. So this side is parallel to this side, and this side is parallel to this side. Since the sides are congruent and they're parallel, what do we know about kite? Since they're congruent, because congruent, and we know that it's a parallelogram, because they're parallel. So our properties are that it has all the properties of a parallelogram and all the properties of a kite. The diagonals are perpendicular to and bisect each other. Since we are parallel and perpendicular, we know that they're bisectors and they're perpendicular bisectors of each other. Kind of powerful stuff. And each diagonal bisects the opposite angle. So these are also angle bisectors. The last figure we're going to talk about is a square. Quadrilateral that has all the sides and all the angles congruent is a square. Now this is also the only quadrilateral that is a regular, this is a regular polygon. It has all the properties of a parallelogram and a rhombus. So it has everything. This is the most specific quadrilateral. So here is the relationship. So we start with quadrilaterals, then it breaks off into two branches. It breaks off into trapezoids and kites. Then trapezoids go to parallelograms, and then kites go to rhombus, and parallelograms can go to rhombi or rectangles. And rectangles go to squares, and rhombi go to square. And square is the most general. If we go down, we're going to specific. If we go up, we're going to general. And this is how the properties work also. You will need to know the properties, because that's how you show figures and that's how you draw figures, and you'll need those properties even when you get into your architecture classes, because you'll have to find whether or not something is a parallelogram, whether or not something is. You'll also need to kind of do the same thing with triangle. Let me know if you have any questions. Thanks.